Plus, we cover basic concepts of probability. We talk about the values of possible value of probability. We talk about odds, which are used in lottery and gambling. So today we are going to talk about the addition and multiplication rules of probability. So addition rule, the notation for addition rule is P of A or B, probability of A or B. So either event A occur or event B occurs, or they both occur as a single outcome of a procedure. We're gonna talk about it much further. So or means the word or in this is the addition rule, right? So you're adding the probabilities. P of A or B will be the most part P of A plus P of B. Uh, Now multiplication with basic multiplication. P of A and B. So the word N means multiplication. You are multiplying the probability. So which is the probability that event A occur and event B occur. But event A occurs first, then event B occurs next. Okay. Compound event. When we say compound sentences combining two or more sentences. So compound event is an event combining two or more simple events called compound event. P of A or B is equal to P of, in a single trial, event A occur or event B occur or they both occur, right? Examples later on. So to find P of A or B, all we need to do is to add the number of ways event A can occur and the number of ways event B can occur. But add in such a way that every outcome is counted only once. Counted once. So P of A or B is equal to the sum divided by the total number of outcomes in sample space. In other words, P of A or B is equal to P of A plus P of B, but minus P of A and B, right? Because if A and B occur at the same time, we have to take that one out because that means we're adding them twice. So we have to remove one if they are actually occurring at the same time. So P of A and B denote the property that A and B both occur at the same time as an outcome in a trial of a procedure. So we have to remove that. But if they don't occur at the same time, P of A or B will just be equal to P of A plus P of B. So disjoint event or mutually exclusive. So event A and B are disjoint or mutually exclusive. They cannot occur at the same time. They don't overlap. So those events do not overlap. For instance, when you select someone for a clinical trial who is a male, that's event A. Event B, you're randomly selecting someone for a clinical trial who is a female. So the selected person cannot be both, cannot be male and female at the same time. So there are disjoint events. They don't overlap. So even that are not disjoint. Selecting someone taking statistic in our class, selecting someone who is a female, the selected person can be both. So it can be taking statistic and it can be also female. So these are not disjoint events. Now, so to find P or A or B, as to the word or with addition, to find the value of P of A and B, you add the number of ways, so which means P of A plus P of B minus P of A and B. Again, P of A and B is when because you're counting double if they are overlapping. So that means you have to remove one of them. We talked about this complement in the previous chapter topic 4-1. We use a bar to indicate that event A does not occur. So that's like the complement of event A, right? A bar. Common sense indicates the principle. We are certain with property 1. So the certain property if the property is one, I mean the property is certain. It's certain. It's likely. It's certain that something will happen, right? That either an even egg occur or it does not occur. So it follows that P of A or P of A bar is equal to 1. So P of A plus P of A bar is equal to 1, right? So the P of A and P of its complement A will be equal to 1. As we talk about this on 4-1. So there must be disjoint because there are complement. So there must be disjoint. So that's why P of A plus P of A bar will be just P of A plus P of A bar. We don't need to do minus P of A and P of A bar because they are disjoint. Because that would be 0. So there's no. Now, complementary even. So they are complementary. So P of A plus P of A bar equals 1, right? Or you can just by subtracting P of A from each side, so it's basic algebra. So you just get P of A bar by itself. Suppose you know P of A, you can determine P of A bar, just 1 minus P of A. If you know P of A, you know P of A bar, you want to determine P of A, just want to do 1 minus P of A bar. So it's very. Now let's take a look at this. This is an example, sleepwalking. Based on a journal article, the probability of randomly selecting someone who has sleepwalk is 0.292. So that means the event is sleepwalk. P of sleepwalk is 0.292 based on data. Right. Now, if a person is randomly selected, find the probability of getting someone who has not sleepwalk. Remember, the probability of sleepwalk is 0.292. So now the question is to find the probabilities of getting someone who has not sleepwalk. So these are complementary events. Sleepwalk, not sleepwalk. We have to do just do, because we know P of sleepwalk, which is 0.292. So you just do 1 minus 0.292, which is 0.7708. So this is 3 significant digits, right? 3 digits after the point. Again, the first digit has to be up to the point, decimal point has to be a non-zero digit. So P of not sleepwalk is 1 minus P of sleepwalk. These are complementary events. And again, they are disjoint. So 1 minus 0.292 is this. All right. Now, in addition, multiplication rule, P of A and B, P of event occur in the first trial. So again, the first event that's shown first, we deal with that first. We cannot say P of A and B or equal P of B and A. It's not always that. No, sometimes they could be equal, but for the most part, you follow the order P of A. So even A occurs first, then even B occur in the second trial, right? So P of A slash P of B slash A means the probability of even B occurring after it assumes that even A has already occurred, or P of B in respect to A. So you can notice that it says that way. P of B with respect to A, which means A has already occurred. So we want to find P of B. So to find the probability that even A occur in one trial and even B occur in another trial, multiply the probability of even A by the probability of even B. But be sure that the probability of even B is found by assuming that even A has already occurred. Because if even A has already occurred, that can affect the total outcomes, right? That's very important to pay attention to that. So P of A and B is equal to P of A times P of B with respect to A. Again, P of A and B is equal to P of A times P of B with respect to A. Independent event. We're going to go over some example of the multiplication rule. Two even A and B are independent if the occurrence of one does not affect the probability of the occurrence of the others. Several events are independent if the occurrence of any does not affect the probability of the occurrence of the other. If A and B are independent, they are are not independent, they are said to be dependent. So if the events are not independent, they will be dependent, right? Which will affect the actual multiplication rule, right? We go over some examples. So for instance, screening drugs in the basic multiplication rule. 50 test results from the subject who used drug are shown below. Positive test result 45, negative test result 5. So you can see here the total test is 50, right? 50 tests conducted. Now, question is, if two of these 50 subjects are randomly selected with replacement, find the probability that the first selected person had a positive test result and the second selected person had a negative test result, right? So here we are dealing with two events. Probability of first person selected had a positive test result and the second one selected had a negative test result. Now, question B, repeat power A by assuming that two subjects are selected without replacement. So when you say without replacement, I mean, if you pull one out, you don't replace it. With replacement, you pull something out, you replace it, right? Power B, repeat power by assuming that the two subjects are selected without replacement. So just when you hear replacement, that means when you pull something out, you replace it when you're doing the second pulling, before you do the second pulling, right? But if you say you hear replace without replacement, I mean if you pull something out, you don't replace it before you do the second calculation. Now with replacement, first selection with 45 positive test result among 50 test result, total result, the P of positive test results is equal to 45 out of 50 because 45 people were tested positive. Now, second selection with 5 negative test results among the same 5 total 50 selection. With, remember, with replacement. So that means you still have 50 test result. Nothing is, there is, we replace, we select, we pull them out, but we put back in because we replace it. Okay. So we still have 5 out of 50 because 5 people were tested negative. Now we apply the multiplication rule. So P of the first selection, which is a positive test result, 45 out of 50, and the second is negative, so 5 out of 50 is P of that. So you multiply them, you do 45 times 50 divided by 50 times 50, and you get 0.900. Now, without replacement, right, without replacement of the first subject, the calculations are the same as in part A, except that the second probability must be subjected to reflect that the fact that the first selection was positive and is not available for the second selection. After the first positive test result is selected, we have 49 test results now. After you pull one test, so you have 49 test results, and 5 of them are negative. So now the second probability is therefore 5 out of 49 because you did not replace the first subject you pulled. Now P of selecting the first selection is positive and the second one is negative. So 45 out of 50 is P of selecting is positive. Now time the second one, second is negative. In the world of statistics, sampling methods are critically important in the following relationship holds. Sampling with replacement, selection are independent event. So independent event. Sampling without replacement, selection are dependent event. So without replacement, there are dependent event. They depend on each other. 5% guideline. When sampling without replacement and the sampling size is no more than 5% of the size of the population, you treat the selection as being independent, even though they are actually dependent. So if the sampling size is no more than 5%, you can treat the event are independent. So for instance, assume that 3 adults are randomly selected without replacement from the 247,436,830 adults in the United States. Also assume that 10% of adults in the United States use drugs. Find the probability that the 3 selected adults will find the properties that the three selected adults all use drug. Three selected adults. Remember, assume that 10% of the adults in the United States use drug. 10%. So, because the three adults are randomly selected without replacement, the three even are dependent. But the problem is, here we can treat them as being independent by applying the 5% guideline, 5% of 200 something million. So only the sample size is only 3. So it's much less than 5% of the population size. So therefore, we can treat this as independent event. So P of all 3 adults use drug, P of first uses drug, and second uses drug, and third uses drug will be P of first uses drug times P of second uses drug times P of third uses drug. So each one is 0.10 because we consider as independent. They don't affect each other. That's why these numbers stay the same. So 0.10 times 0.10 times 0.10 is 0.0010, right? And so there is 0.0010, 100 probabilities that all 3 selected adults use drug. So this is called principal redundancy. Is used to increase the reliability of many systems. Okay, so you can read this. Just an example. Elvis 10 redundancy for better safety. Modern aircraft are now highly reliable, and one design feature contributing to that reliability is the use of redundancy, whereby critical components are duplicated, so that if one fails, the other will work. For example, the Airbus 310 twin-engine airliner has 3 independent hydraulic systems. So if one system fails, full flight control is maintained with another functioning system. For example, so if the Airbus 310 were to have one hydraulic system, what is the property that the aircraft flight control will work for a flight? Now, given that the Airbus 310 actually has 3 independent hydraulic systems, what is the property that one typical flight control can be maintained with a working hydraulic system? For one, failure, the probability of hydraulic system failure is 0.02. So the probability that it does not fail is 0.998. You just do 1 minus 0.02 to get 0.998. That is the probability that the flight control can be maintained as is followed. So 1 minus 0.02. With 3 independent hydraulic systems, so 3 independent, so that will be 0.02 times 0.02, 0.002 times 0.002 times 0.002, because they are independent. First one, second one, third one. P of, so it's a multiplication rule, so we get 0.00008. So it follows the property of maintaining flight control is as follows. P, it does not happen that all 3 hydraulic systems fail, is this, 1 minus 0.08. Right. So with only one hydraulic system, we have a 0.02 probability of failure. But with 3 independent hydraulic systems, there is only 0.0008 failure. So you can see here, with 3, the chance of failure is much lower, right? Probability that the flight control cannot be maintained because of the 3 system fail. All right, so this. Now, the summary addition and of addition rule and multiplication. Addition rule for P of A is again the word or suggests addition. The word and suggests multiplication. And the word and for 2 trials suggests multiplication, and when multiplying P of A and P of B, we must be sure that the probability of A, event B takes into account the previous occurrence of event A.